Welcome to this talk about Klutch, an exciting new open source technology, which we'll have a greater look right away. So first of all, my name is Julian Fischer. I'm CEO of a company called Any9s. We are focused on platform automation with a strong focus on data service automation and data service integration for large-scale application developer platforms. We've been doing a lot with Cloud Foundry and Kubernetes in the past years. So that's how we actually came to the problems leading to Clutch in the first place. So this talk is basically, this is the talk abstract, and it basically describes how Clutch is open source and how it helps to simplify Postgres automation. And it does that in an infrastructure agnostic way, and we will see how this works. Um, the target audience for Clutch originally are organizations that have hundreds or even thousands of Kubernetes clusters, which are used by application developers. And these application developers, they should get a high for managing the lifecycle of the databases, for example, Postgres. This will result into thousands of um, Postgres instances being operated, assuming that there are hundreds or thousands of Kubernetes clusters, there will likely be hundreds and thousands of applications, and hundreds and thousands of applications will depend on hundreds and thousands of data services, including many Postgres databases. And we'll also talk about how Clutch on one hand helps to decentralize by separating applications from cloud services, but at the same time helps to centralize metadata information um, by storing this metadata information or this meta information in one particular place, the Clutch server. We also see how this pattern enables high operational efficiency and thus reduces the operational overhead in the teams. Streamlining database management with on-demand developer self-service. I mean, that's what we're talking about in the cloud. Application developers should be able to get their databases at any time, whenever they want, without the involvement of other people. We'll also see how Clutch allows the usage of multiple automation backends. So you could have different variants of Postgres, or you could have other data services, both infrastructure provided, let's say Amazon RDS, versus an on-demand provisioning, fully automated product like the Any9s data services or any open source operator you prefer. So, or multiple automation backends is a thing we'll talk about that. All of Clutch is, first of all, offering Kubernetes native interfaces to the application developer and the platform operator, and itself is basically a set of Go operators, operators written in Go. And we'll also see how Crossplane is leveraged to write automation backends. All right, so let's jump into it. So we'll go through questions like what is Clutch, when is Clutch being useful, and what are the basics of Clutch and how does it work? What does Clutch do for Postgres and where is it now and where is it headed? All right. So first of all, a few words about the motivation for Clutch in the first place. So in our experience, Kubernetes, the fantastic technology it is also at the same time a technology that, when adopted by large organization, leads to certain challenges. And one of the challenges that we see is that there will be and there are a lot of Kubernetes clusters. The bigger the organization there is, the more developers there are, the more Kubernetes clusters will be there. So the elephant in the room, in this case, not Postgres elephants, but actually, well, yeah, if you need to create a lot of Postgres, then that's your elephant. The elephant in the room in our perception is the cloud service challenge for large-scale developer platforms. In other words, like say you have a Cloud Foundry, you have lots of Kubernetes clusters. In each case, you have hundreds or thousands of apps but these hundreds and thousands of apps, they usually depend on hundreds and thousands of service instances. And the question is, well, there's something that handles application deployment quite, elegantly. What is actually the counterpart for data services? Well, in small scale, Kubernetes platforms, you might think of, well, let's just use operators. Well, an active part of the data on Kubernetes um, a community, and we believe operators are, a very interesting pattern for data service automation. So you might start with the idea, let's just make the Kubernetes cluster, self-sufficient and use operators for that matter. So the idea of local operators in this context, I'm referring to local in the sense that the operator is running in the application cluster. So if there's application developers and they have a cluster, and this cluster contains both the application and data service instances, and we're looking into the question whether this is a good approach when the platform gets bigger. One question is here, a bit jokingly, are you looking for developers or are you looking for unicorns? Because the problem with that particular pattern is that if you want to run your databases, Postgres, for example, alongside your applications, that also means that you need to have a cross-functional team. So your application developer team need more skills than if the data service automation would be run by a different team. Um, And if you happen to require other data services as well, the demand of skills, both from application developer perspective, like developing the application, understanding the problem domain, and understanding the database from the application developer's perspective, is not enough. You also need to understand the operator's perspective. You have to have a certain a DBA, database administrator knowledge. You need to have DevOps knowledge. You need to understand how lifecycle managing of Kubernetes operators, for example, work, including, disaster recovery scenarios, covering them, as well as certificate rotation, updating the automation, and all of that needs to happen while writing application code and ideally having very little impact on the application operation itself and the availability of the overall cluster. But by the just by the sheer fact that you have this large set of skills that your team needs to have, um, recruiting people for your team becomes harder. So you either train those skills or you recruit them, and both takes time and costs money. And now think of having a lot of clusters. So for larger scale platforms, then when you add more clusters, at some point you have so many of them that, well, maybe you even won't get to this stage because before that you will run out of people in your teams with the appropriate skill set. You might not be able to train up people quick enough to scale to that extent in the first place. And if you get to that extent, it's going to be hard to acquire those people in the free market as they are rare. So, in our experience, none of the large organizations went really far with that approach. Also, because the responsibilities of application developers combined with the operations of data services have tremendous downsides in that application developers can never really specialize on dealing with the life cycle of a database the same way a DevOps would that is solely focused on that particular data service or a small set of data services, but does not have to, think about domain problems, application domain problems. So in our experience, that's not really what large organizations do. And if they do that, it's a quite costly endeavor. So one of the first things to do is to separate the automation backend from the application developer, which creates several advantages. And for example, you remove the operational overhead from the application clusters by moving the operator to some other place, in this case, a central place, which means that you have one place where data services are being operated, and you have another place where applications are being hosted. Well, this, of course, helps insofar that the application developer now does not have to come with that large skill set, which means that you can more easily hire people into application development teams. You don't require them to be as cross-functional, covering such a wide spread of skills. At the same time, at the first step, this also introduces a bit complexity in the sense that you still want to have that local on-demand developer self-service. So how can a developer now create a service instance where, with the earlier approach of the local operators, you would just have to, interact with the operator. And that's exactly what Clutch is addressing, as we will see in the future, in the next slides, very near future. So Clutch is an open source technology to address exactly that problem. It's licensed under the Apache 2 license. And here we are talking about Clutch in a nutshell. So, as I said, the first thing to acknowledge here is that there are Kubernetes clusters on the left side running application systems. They could be owned by different application developer teams, for example. And the data service automation is separate from the application cluster, and that's enabled by Clutch. And it's done by installing a lightweight extension to every local application cluster, which integrates with the Clutch server, and the Clutch server integrates with the automation backends. So why is that? And the answer is the local Clutch connector, as it is called, it introduces local custom resource definitions to represent all the data services and their functionality, the lifecycle management functionality in the local application cluster, generating exactly that user experience of on-demand self-service. So every application developer can just create a service instance at any time by creating an object in the local application cluster. All these objects are then replicated to the central Clutch server or Clutch control plane, which on its own is a Kubernetes workload sitting either next to the automation backend or in a separate management cluster. It can be operated by a platform team. Now, depending on which automation backends you have configured, various different data services or very different variants of a particular data service can be exposed through Clutch to application developers for on-demand self-service, while the service instances are actually, centralized or at some places where specialized DevOps can properly take care of them. So as I said, this is the control plane, so to say, the server of Clutch. This is where all information is also being stored. And the local application cluster, whenever you create an object there, it's basically like a proxy object for the actual service instance. And this proxy object is then replicated to the Clutch server, and the Clutch server reconciles using the actual automation backend to create and manage the actual data service. So the Clutch server always knows where are the service instances and what is their desired state. And it does so also for the other abstractions that come with Clutch, including service bindings, backup, restore, as we will discover a bit later. This is the Clutch connector. As I said, it's a very lightweight local set of operators that introduce custom resource definitions, introducing the abstractions that come with Clutch. It's all native Kubernetes operators. It's written in Go, if that's important to you. And one of the main ideas here, as I already said, is the separation of the service instances from the application clusters to get to a higher operational efficiency. So because you can also integrate many different automation backends, basically Clutch is the, Clutch provides a standard way on how to expose arbitrary cloud services across a large set of Kubernetes clusters in an elegant and harmonized way. So, for example, if you want to expose a cloud service that you have created yourself, let's say it's one application team that creates such a cloud service, you can use Clutch and write a Clutch integration and expose this to other users in your organization in the same on-demand self-service as if um, the cloud service were exposed locally in the cluster. Now, integrating new backends with Clutch is also an exciting thing because you want to go a contemporary path. And, given that Crossplane is a widely adopted technology that, reconciles external resources from Kubernetes clusters in an Kubernetes idiomatic way, it was quite, easy to say that Clutch will help a lot. Crossplane will help a lot when implementing Clutch. So Crossplane's purpose in Clutch is to provide a large set of already existing integrations, accessing and representing external resources that can then be used to do data service automation and can be exposed via Clutch in a more streamlined fashion as we map the Clutch abstractions to anything that's utilized by Crossplane underneath. So if you think, for example, for a Postgres automation, let's say Amazon RDS, it's not enough to create just an Amazon RDS instance. You also have to create an IAM user and policy. So you'll be handling multiple objects. So where Crossplane allows you to represent those individual objects, it does not really provide you with a fully fledged Postgres experience where application developers can just say, give me one Postgres instance, and there you go. And this gap between what Crossplane does and what application developers want is what Clutch bridges. So also, because you can plug in arbitrary or automation backends, it is and Kubernetes and Clutch is a Kubernetes workload, it also operates across infrastructures with ease. So here are a few ideas on how to use Clutch. Um, and in this scenario, you'll see that there's um, two different on-premise clouds being used. On the left side, you have a region with OpenStack, and on the right side, there's a region using VMware. In both cases, you could have, also hundreds of Kubernetes clusters. There will be a local Clutch installation, and you can integrate automation backends that are on-premise capable. So we at Any9s, for example, we've developed the Any9s data services, VM-based on-demand provisioning of dedicated service instances using BOSH, BOSH as the automation technology underneath. They will work across infrastructures, and the AWS Postgres Kubernetes operator will work, and any Kubernetes operator you'd like that you will extend with a Clutch integration will work as well. So Clutch and on-premise scenarios would therefore allow to operate the data service automation backend apart from the application cluster. Could be VM-based automation, as I said, with the Any9s data service, could be operators, doesn't really matter. Clutch abstracts, provides a harmonized set of abstractions, service plans, service instances, service bindings, backup and restore objects to local clusters, and hides the underlying complexity. So with that, application clusters can create databases on both on-premise and public clouds. As you can see here, for example, the same backends are available on public clouds. As I said, well, our backends are available on all major clouds. Open source operators will be available on all the clouds. But if you want to consume infrastructure provided services, no problem. You can integrate them with Clutch too and expose them in a much easier way than it would be without Clutch. So in particular, if you create a Kubernetes cluster, let's say on Amazon, and you want to create an Amazon RDS database, well, what would you do? You'd have to step outside of the cluster to get a database hooked up to your application in the sense that you have to create the service instance, you have to create the IAM user, you have to create the policy. And this is all being handled by Klutch with a proper integration. That means the application developer can describe it, the application system completely, comprehensively with both the application and the dependent data services. And whenever you throw this specification of the application system against an empty Kubernetes cluster running the Klutch client, it will reconcile and create a database and deploy the application in one Kubernetes native way. I mean, think about what that does to uh, GitOps. It brings your GitOps experience to the next level. You can do that across all major platforms, of course. Any cloud service can be integrated with Klutch. So plenty of Crossplane resources are already there. So we are implementing cloud services from Amazon at the moment, but others will follow pretty soon. So that will allow consuming databases across infrastructures from within application clusters in a Kubernetes idiomatic way seamlessly and easily. So these services are infrastructure specific and can be integrated with Klutch. So now where we know what Klutch actually does and have some understanding how it does it, separates application clusters from data service automation backends while having the central place where everything is stored. You might wonder how does this feel for application developers? And that's what we're looking into next. So Clutch introduces a set of abstractions. They are well known from the Open Service Broker API, which originates from the Cloud Foundry community. They have been battle tested and they are well proven. Clutch extends the Open Service Broker API and also provides backup, restore, and abstractions for creating backup plans, as we've learned in the past decade that this is also essential for developers to have their own self-service backup and restore um, functionality to be really self-sufficient. So service plans, they are basically the idea of a t-shirt size. So you want you want a database in a particular default configuration, let's say small, 8 gigs of memory, for example, that a service plan could represent. You could have different service plans for different sizes, different flavors of the database. Here, in case different Postgres, you could have service plans for synchronous and for asynchronous streaming, replication, or for solo or clustered instances, and plans for various sizes. So application developers, all they have to do is choose a service plan and they will get reasonable, well-tested configurations. By creating service instances, they refer to a service plan and thus choose the particular flavor of the Postgres they want, in Postgres example. And whenever a service instance is already there and you want to bind an application to the service instance as well, then you create a service binding, which will trigger the creation of a database user and also creates a Kubernetes secret in the local application cluster to readily just consume the secret and thus use the service instance. Well, backup restore, self-explanatory. You can also declare, I want a backup to be restored, given that there's a service instance. So this is how a service instance looks. It's a YAML spec, just like any other custom resource definition, um, custom resource object, or Kubernetes native object for that matter, is just expressed here. And you can also see that in this case, for example, there's ANS Postgres versus ANS Postgres. This is basically these are examples for two different automation backends that we already implemented in Clutch. The ANS Postgres is here in this case referring to a single nano plan, which means that it is a small container using the Kubernetes operator that we've built. And in this case, it's VM-based automation, also single, also nano, which means one virtual machine, and in the other case, a pod. So as you can see, the abstractions provided by Clutch help to harmonize the experience also of consuming multiple flavors of a particular data service implementation, in this case, Postgres. So furthermore, if you look in this example, this is how you'd consume, how you'd create a MongoDB service instance for yourself. And as you can see, it's also referring to the service plan and looks pretty much like the configuration for a Postgres database, which means that you have now a general abstraction for service instances. And that allows you to also create CI/CD tooling that's more harmonized because you don't have to deal with all the details of the underlying database too much in your CI/CD and your GitOps repository. So once you have a service instance, you may want to consume the service instance by connecting your application to the service instance. And this is what you do with the service binding. The service binding creates in Postgres a username password in the database instance, but it also creates a Kubernetes secret in the local application cluster. So all your application has to do access the secret and thus gain access to the credentials necessary to connect to the actual database. So now, last but not least, here's a little recording on how uh, this actually looks um, you know, in a demo. So you can see the connectors there, which is the Klutch client. We're looking here at a service instance spec as you've seen it just before. So in this case, we are creating a medium, a small-sized database, Postgres version 13, using AWS Postgres as backend, which means that we are creating a pod as a service instance. And once you have applied this, the metadata is replicated to the Klutch server. The Klutch server delegates to the backend, and the backend will create the service instance. In this case, as you can see, Postgres has been created. So a service binding is being created here, which means creating a database user and a secret. We'll apply the service binding, and what we'd expect to see is a service binding object. Yes, it's there, and a corresponding secret. So here we go. So if you have a closer look at the secret, you can see that the secret contains, let's say, a username in this particular example. All right. I mean, similarly, you can create backups and restore, but as you can see, the application developer interacts with the local application cluster, and Klutch takes care of the rest. So while you have this experience as if, um, Klutch was operating the data service locally, they are actually someplace else. And now also you have to understand this is not creating a direct connection between the application cluster and the automation backend because it funnels through the Klutch cluster, the Klutch server. Um, the Klutch server therefore knows where all the service instance and the service bindings are, which means you can easily ask a question, hey, where are Postgres 13 versions and um, when are they going to be upgraded, or let's say on Postgres 15 or anything, you'd be able to set a notification to observe and ensure that service instances are properly migrated throughout the evolution of Postgres. So this won't be possible if you use, let's say, Crossplane directly in application cluster, directly talking to Amazon RDS. You won't get those neat abstractions that keep things really simple, and you won't get Klutch as a central metadata registry, knowing where all the service instances are located, which becomes kind of important if you have a lot of clusters and a lot of service instances. You really want to keep your environments tidied up. In this regard, Clutch also builds the foundation for doing things like dynamic security, firewalling between service instances and application clusters, but also do, internal cost allocation by knowing where service instances actually existed, helping to allocate cost and generate billing information. So now, with all that being said, it's up to you, and we really need you in the Clutch community to understand what we can do better. So please go and try out Clutch. Uh, Give it a star on GitHub if you like it. If you want to reach out to us and get a demo, or um, even get a free POC on your infrastructure if you're interested in. But if that's all, let's say asking too much, there's going to be a self demo available later in November, which means that there's a tutorial that allows you to download, that shows you how to download Clutch on your local machine. Let's say using Minikube or Kind, simulating the application cluster, connecting the application cluster to Clutch, and use, let's say, a Postgres Kubernetes operator as an automation backend so that you can walk through the user experience of using Clutch yourself. If there are any questions, please feel free to reach out. Um, would be a pleasure talking to you. There's also a Slack channel referenced on clutch.io, which is the website you find Clutch on. So feel free to join there and ask questions through there. Thank you very much for your time, and see you soon.